There we go. So again, this is number 6. A of t is equal to 2t plus 6, where v of 0 is equal to 8 and s of 0 is equal to 5. Okay, so that's the original problem, right? Remember that if I want v of t, that is the antiderivative of a of t, right? So that means 2t squared over 2 plus 6t plus c. Or in other words, t squared plus 6t plus c. Now, the good part about the extra information is, what is my c value in this case? 8. So v of t is equivalent to t squared plus 6t plus 8. Okay, let's find s of t then. So s of t is the antiderivative of v of t. So it's t to the third over 3 plus 6t squared over 2 plus 8t plus, we'll call that d. Okay, so in other words, I'm gonna make that I don't know. What did I do with my key? 1/3? Doesn't really matter. Yeah, 1/3. 1/3 t to the third plus 3t squared plus 8t plus d. And to finish it off, I know that since s of 0 is 5, then s of t is 1/3 t cubed plus 3t squared plus 8t plus 5. There's position. Good there? What else do we want to look at? Give me another one. 18. 18 all the way in the back. 18. Number 18 says, from 1 to 4 of x to the third minus 2x to the 8th over x to the 4th dx. All righty, so I got to evaluate that down. I don't know any sort of quote or like a rational function rule. So I got to look at this. Okay, that's an x to the negative 1. Actually, you know what? I'll do it step by step. Change colors too for emphasis. X to the third over x to the 4th minus 2x to the 8th over x to the 4th, which is x to the negative 1st minus 2x to the 4th. Right? Just reducing down that rational function into something that looks more polynomial-ish. Okay? Which means I'm going to find this 1 to 4 of x to the negative 1 minus 2x to the 4th dx. Let's find the antiderivative. Now, what's the antiderivative of x to the negative 1st? ln of absolute value of x minus 2x to the 5th over 5 from 1 to 4. The absolute value doesn't play a role here because I don't have any negatives going in, but it's always good to remember that. So this is ln of 4 minus 2 times 4 to the 5th over 5, all minus ln of 1 minus 2 times 1 to the 5th all over 5. And we evaluate. Let's do the left side first. We've got ln of 4 minus 2 times 4 to the 5th divided by 5. That seems like a really big number. Is that correct? Let me check the key. Is that what you got? Okay, good. Yep, negative 408.21. Negative 408.21 minus, okay, on the other side, we got basically the same thing, but now I'm going to plug in 1. Whoops, way too far. 1, ln of 1 minus 2 times 1 to the 5th over 5. Negative 0.4. Minus 4/10. All right, so that's really kind of plus 4/10, but anyway. Negative 408.21 minus negative plus 0.4. Negative 407.81. Good there? Okay, what else? That's 2 over 25. Give me a third one. 7. Siete. Okay, here's 7. Ooh, it's the picture one, right?
Yeah.
So estimate the area under the graph of 1 over x from 2 to 4 using 4 approximating rectangles and right endpoints and left endpoints. Please sketch the graph for each approximation. So I'll do it the same way I see in my key. I will do the right side first, and then I will do the left side second. All right, so if I want to use 4 approximating rectangles, and I'm going from 2 to 4, this is what it's going to look like. All right, so here we have it, 1 over x, 1, 2, 3, 4, right? So basically what I have here, if it's 1 over x, in just the first quadrant there, it's going to look like this, right? All total. So if I want to split it up, there's 1, 2, 3, 4. Now, think about 4 approximating rectangles. Okay, 4 approximating rectangles. That means I'm going to use small dash, small dash. Here's 2, 3, and 4. This is 2.5 and then 3.5, right? My 4 approximating rectangles with right endpoints would be here. Oh, let me use red. Here, 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 and then here. Right? Those are my 4 rectangles that I want to find. I'm going to do that exact same thing. We draw. Ooh, you know what I'm going to do? No, I'll just redraw it. I was going to try to copy paste it or something. So 1, 2, 3, 4. Here's 2. Here's 4. Here's 2.5. Here's 3.5. I know that it's going to look generally like this. And that means we are going to have the area from here to here. And if I want to use left endpoints, that means I'm going to go here, 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 and here. Right? See, right by my picture alone, I know that my right is going to be an under approximation and my left is going to be an over approximation, right? I know my right is going to be a bigger value or smaller value than I want, and I know my left is going to be a bigger value than I want. All right, so let's do it. Let's actually evaluate it. So that means, am I going to be using 2 as one of my values? No, my first value is 2.5, isn't it? Yeah. So that means, looking here, what's the width of each rectangle? 0.5. So this is 0.5 times f of 2.5 plus f of 3 plus f of 3.5 plus f of 4. See, this one I will be using f of 4. Will I be using f of 4 down here? No. So I can write it here. Okay, this is 0.5 times f of 2 plus f of 2.5 plus f of 3 plus f of 3.5. Right? Now remember, our f is 1 over x, isn't it? Yeah. So this is really like saying 0.5 times 1 over 2.5 plus 1 over 3 plus 1 over 3.5 plus 1 over 4. Same thing here. This is 0.5 times f, no, I know what f is, times 1 over 2 plus 1 over 2.5 plus 1 over 3 plus 1 over 3.5. Okay. And I'll be a little cheater beneater here. 0.635. Oh, I don't know why I did a parenthesis at the end. And on the left side, it looks like 0.75 or 0. 0.759. Oh, whatever. Looks like I went 0.7595. Rounded 0.76 if you want to. That's it. Yep. Here's the right side approximation, 0.635. Left side approximation, 0.76. Can we do? We got 4 minutes. You want to do one more?
Yeah.
Which one do?
Never did it.
21?
Yeah, there is no 21.
There's no 21. What am I doing? I didn't even do a 21. I was wondering because on my key up here it says.
Oh, what about 23?
It says no 21. Oops. Which one?
23 or 24?
23 or 24. You pick. 23? Okay. So 4 plus 6x over radical x dx. Okay. So basically what's going to happen is this. I'm going to say 4 over radical x plus 6x over radical x. Reduce that down. So this is like saying 4x to the negative 1/2 plus, okay, so that would be 6x over x to the 1/2, right? So when I divide exponents, I subtract, or when I divide powers, I subtract them. So that means this is going to be a 6x to the 1 minus 1/2 is 1/2, right? All right, so to find the antiderivative then, I take, okay, 4x to the 1/2 over 1/2, right? I kick it up 1. And then this would be plus 6x to the 1.5 over 1.5. You could use fractions, decimals, really doesn't matter there. So this is, what's 4 divided by 0.5? That's 8, right? So 8x to the 0.5 plus 6 divided by 1.5 is 4. 4x to the 1.5. And that's going from, it's not going from anything.
So that's it.
Yeah. Don't forget, we have to do the plus c. Why do we have to do the plus c? Because it's an indefinite integral.
Oh.
Remember, indefinite integral are most like antiderivatives, the general form of the antiderivatives. All right, we'll pick up there tomorrow. Sound good?